Alright, so in this video we're going to discuss work and power for rotational motion. So remember, work was force times displacement. So we're looking at work equaling force times displacement. But let's think about what's going on here. So say we have some sort of wheel and it is rotating about its center. So in order to get it to rotate, you're applying a force at some point that is perpendicular then to the lever arm, and the lever arm would be the radius of the wheel. That's going to cause this point on the wheel to rotate to some new point, which is going to be our ds. Now remember that ds is equal to r times d theta. So d theta is going to be the angle in here that rotates through, which means I could go back over here and rewrite my formula as force times r times d theta. I know it makes more sense in terms of rotational motion, where work is going to equal force times r, which would be the torque, times the change in theta. So this is one way of calculating work done in order to change rotational energy. Let's expand this a little bit further though. So we're going to start back here with work equals torque times the change in theta. And we're going to use our other half of the torque equation here. And remember, angular acceleration is the same thing as the first derivative of the angular velocity function. So I'm going to do a little bit of a switcheroo here. And remember that d theta dt is the same thing as the angular velocity. So now I can integrate from initial velocity to final velocity. And that gets me that my work is going to equal, I need to evaluate from initial to final. We're going to divide by 2 because we integrated. And so we end up with 1/2 moment of inertia angular velocity final squared minus 1/2 moment of inertia angular velocity initial squared. So notice that this looks awful familiar. So 1/2 moment of inertia times angular velocity squared is kinetic energy. So we can say that, once again, our work is equal to the change in our rotational kinetic energy. So this is work due to rotational motion. Alright, so the last thing we need to talk about here is power. So we're going to go back to our work equation. Work equals torque times d theta. And we're going to divide both sides by time. Or the change in time, I should say, dt. And remember, work is already the same thing as the change in energy. So energy divided by time, we learned earlier in the semester, was power. And that's going to equal torque times d theta dt. And remember, d theta dt is the angular velocity.